Welcome to this today class. We're looking at statistical analysis. And under statistical analysis, we're looking at descriptive and inferential statistics. We'll look at under descriptive statistics, we look at measures of central tendency. And the first one is the mean. But before I go to this, let me briefly talk about statistics. Statistics is the foundation of data analysis and data science. Data science and data analysis, they evolve from statistics. Statistics itself evolved from mathematics. Statistics is a branch of mathematics. So in previous times, it was statistical analysis that was known until the advent of computer technologies, that we now have a separate field as data analysis. But you cannot do data analysis without having some understanding of statistics. So statistics is made up of two categories. There are two types of statistics. We have the descriptive statistics and the inferential statistics. In our introductory class, I talk about descriptive analytics. So that is where it comes from. When you make a description of the situation, you make description of the data set that you have, then you run descriptive analysis. By the time you begin to make judgments about the population, then you are making inferential statistics. So under descriptive statistics, we have two types of measures. We have the measures of central tendency and the measures of dispersion. So the measures of central tendency tries to measure how the data tends to a particular value, and one of those values is called the mean. So what is the mean? If you have n set of numbers, you have set of numbers number 1, number 2 up to number n. Those numbers are what we term here as x1, x2 up to xn. Then the mean of that data, denoted by x bar, is given as follows. Is given like this. That is, x bar, you sum all the x values that you have. You take x1 plus x2 plus x3 up to plus xn. Then you divide it by n. N is the total values. If you have 100 data, your n is 100. If you have 20 data, your n is 20. So it can also be written in a compact form, as you can see at the right hand side. That is, s1 plus s2 up to sn over n is the same thing as the sum of xi for I equals 1 to n all over the total n. So the two means the same thing. If you have data values, you are adding it, this plus this plus this plus this. In a mathematical term, it is written like this: is the sum of all the x value that you have divided by the total values. So now, if those x values that you have, they have corresponding frequencies. For example, you are measuring a data about the weight of children, and those that weigh 30, there are 5 of them. Those that weigh 31, there are 6 of them. Those that weigh 35, there are 10 of them. So the number that each value occur is called frequency. So it means that x1 has a frequency of f1, s2 have a frequency of s2, s3 has a frequency of s3, and so on up to xn, which has a frequency of fn. Then if you have such a situation, the mean is given like this. The mean is now the sum of the frequencies times the xi divided by the total sum of the frequency. So you, instead of having x1 plus x2 plus xn, you now have x1 times f1 plus s2 times f2 plus s3 times f up to fn times xn, all over the sum of fi. If you sum all the f, that will give you your n. So example, we are to calculate the mean weight of 85 school children whose weight were measured to the nearest kilogram as given in the table below. This is a table. This table gives the weight of 85 school children. So now, this is what I explained in that second formula. You have weight from 25 to 37, sorry, 25 to 27, 28 to 30. So it is a group data. Now it has corresponding frequency. So for you to find the mean of this data, this is what you do. You now take this tabular value like this. The weight in kilogram is what has been given, but it is not giving specific values. They are divided into groups. You have group 25 to 27. Those are the weight of 25 to 27 kg. Those are weight 28 to 30 kg and so on. But you cannot work with such value. So to do that, you have to take the midpoint. You have to take the midpoint of those weights. So the midpoint of between 25 and 27 is 26. How do you get it? You take 25 plus 27, it will give you 52. And then when you divide 52 by 2, it will give you 26. That is how we got that midpoint as 26. The same thing for the second class. You have 28 to 30. So if you take 28 plus 30, it gives you 58. And 58 divided by 2, it will give you 29. That is how you take the s values. So those mid values are your x that you will now input in the formula. Because the formula we have f times x. Now we take our s and then we have our f that has been given from the table. The f here is where we are not the one that generate the f. The f has already been given in the table like this. Look at, those are the frequencies. We have 5, 12, 20, 20, 15, 8 and 15 and 5 rather. So they are the same values that we have here in this f frequency, in the f column. So you now take your f times your x. You now do 26 times 5, you have 130. 29 times 12, you have 348. 32 times 20, you have 640. And you do all of that. And then you sum it. Because in the formula you are taking is a summation. You take all the sum. What it means is that you are doing 5 times 130 plus 12 times, you are doing 26 times 5 plus 29 times 12 plus 32 times 20 plus 35 times 10 in that order. That is what it means. So but you already done that in the table here. So when you go to your formula, you just input and get your result. So when you sum all the frequency, you have 85, and you sum all the value of frequency times x, then you have 2936. So going to the formula now, this is a formula. We have sum of fi times xi all over the sum of the frequency, and the sum of those f times x, all of them we got from the table is 2936 divided by the total frequency, which we got as 85. And when you do the arithmetic, you get your mean value to be 34.54 kg. So the mean weight of those school children is 34.54 kilogram. So that is how you calculate the mean manually. All this we can do it with Excel, we can do it with Python, we can do it with SQL, but you have to know the foundation. Because if we now ignore those foundation and start working only with the software, you never can tell what will happen tomorrow. Maybe, okay, now for example, Excel now is owned by Microsoft. What happens if Microsoft collapse? There's no longer Microsoft as a corporation. So what can we use? Or things like Python, those that develop all those software, maybe along the line nobody knows tomorrow, because we didn't know that we'll have those things today, but we have them. But you cannot tell what will happen tomorrow. Something, because take for instance, there was a time in this year that there was a network breakdown. There was network cable that was cut along the ocean, and the whole of Nigeria did not have network. Our banks could not function. Nobody saw that coming. So anything can happen. So that is why we must have those foundations. Because if those technologies, maybe anything happen to them, the foundation is there. The knowledge is inside us, where we can use, because it's those knowledge that they use those things to develop all those softwares. Because without these foundations, they cannot develop those software. That is why we are doing this thing here. So some people will be saying, why are we doing calculations here manually when we have the softwares? That is the foundation. So pay attention and grab it. And when you know this foundation, by the time you begin to run your analysis, you will be able to interpret your result correctly. So it's not just about computing your analysis. After you compute the analysis, you should be able to give accurate interpretation of the analysis. So I don't know whether I'm communicating with people here. All right. So let's forge ahead. So now, another thing is called a median. One of the measures of central tendency is a median. The median is a value that divides the data into center. The mid value of a data is what we call the median. For a data that is not grouped, when you just have values like 1, 5, 7, 8, 10 and so on, then you just arrange those values in order of magnitude. You arrange it in order of magnitude. What does that mean? It's either you arrange it in ascending order or you arrange it in descending order. So you now pick the central value. If the values are odd, for example, if they are 11, you now pick the sixth value as your median. But if they are even, if they are 12 for instance, you pick the sixth and the seventh value and then add them together, divide by 2. That will give you your median. But for a group data, this is a formula. For a data that is grouped, like the one we saw in the previous example, you cannot just handpick the median. You have to work it out using this formula. So the median of a group data is given as L plus N over 2 minus CF minus 1 over FM, where L is the lower class boundary of the median class. N is the total frequency of the distribution. Like in the example we saw, the total frequency is 85. That will be your N. And then CF minus 1 is the cumulative frequency of the class before the median class. And then FM is the mean. FM is the frequency of the median class. And C is the class interval. So let's take example so that we see what we are saying here. So the following is a distribution of the masses of junior weight lifters. Calculate the median of the distribution. The table is missing. Okay, the table I think is okay, so this is you look at the mass in kg and the frequency. That is what has been given to us. Now the question is saying we should calculate the distribution, calculate the median of the distribution. The table gives us mass in kg from 51 to 55, 56 to 60, 61 to 65 up to 100 with the corresponding frequency of 10, 15, 16, 40, 32, 25, 22, 18, 12 and 10. So for us to find the median, in the formula we have what is called L, and L they say is a lower class boundary of the median class. So how do we do that? We must find the class boundary. How do we find class boundary? Class boundary is when you go to each class. Here now our first class is 51 to 55. You take away 0.5 from the first value and add 0.5 to the last value. That will give you your class boundary. The essence is that 51 can be the same thing as 55.5 is the same thing as 50, can be approximated to be 51. 50.6 can also be approximated to be 51. 50.7 can also be that. You know, in approximation, when the decimal value is up to 0.5, then you round it up. So here now, for you to capture all the values, you have to take it 0.5 below and 0.5 above, so that you capture all the values. That is the essence. So that is how you take your class boundary. So for the second one, the class boundary is 55.5, 60.5, like that. And then we take the cumulative frequency. How do we find the cumulative frequency? You do 10. The first frequency is 10. There's no other frequency above it. So the cumulative frequency will be 10. So when you come to the second one now, it's going to be that 10 plus 15, which will give us 25. The next one is going to be that 25 plus 16, which is 41. 41 plus 40, 81. 81 plus 32, 113. Like that, if you add all together, you get the total cumulative frequency of 200. That means the total N is now 200. Our N is now 200. So we now go to the formula and begin to pick those values. First of all, how do we know the median class? How do we know the median class? To know the median class, you do the total frequency divided by 2. And the total frequency is 200. So if you divide 200 by 2, you get 100. You get 100. And if you look at the cumulative frequency, 100 is contained in the class interval of 66 to 70. Let me go back to the table. Look at the cumulative frequency here. 100 is between 66 to 70, because after that one, the next value is 113. It's 113. So 100 lies between that value. Between 66 to 70, that is where 100 lies. So that is our class, that is our median class. The median class is 71 to 75. So now, therefore, the median class is 66 to 70. And then our L is 65.5. That is the lower class boundary of the median class. Our N is 200. Our CF, that is the cumulative frequency of the class before the median class. Let's go back to the table again. The median class is 66 to 70, and the cumulative frequency before that class is 81. Sorry, is 41. The cumulative frequency before that class is 41. So that is our CF minus 1. And then the frequency of the median class, that is FM. The frequency of the median class is 32. Is 32. So we now put all those values into the formula, and then we get our median. If we put all this, we at the end of it, the median is 72.88 kilograms. Then we have the mode. The mode is another major or central tendency. And what is the mode? The mode is value that appear more frequent. The mode is the value that has the highest frequency. So the mode of a set of number is that value which has the highest frequency. For a mode of a group data, the mode is calculated using the statistic. We have this. This is the mode of a group data, where L is the lower class boundary of the modal class. Data 1 is the frequency of the modal class minus the frequency of the class before the modal class. And data 2 is the frequency of the modal class minus the frequency of the class after the modal class. Then Fm is the frequency of the modal class. So we have this. So this is the example. Use the data in example 3. We have in the same example that we look at. This is our class boundary and the modal class. The class that has the highest frequency is still 66 to 70. It has a frequency of 7 or 40, which is the highest frequency. So that is the modal class. So then the lower class boundary there is 65.5. And the frequency of the modal class is 40. The frequency of the class before the modal class is 16. And the frequency of the class after the modal class is 32. So you now take those values and put into the formula. Our L is that, our C is 5. C is a class width. From 55 to 59 is 5. So each of them has a class width of 5. So we now do those calculations. This session while we are presenting, that is why I put everybody on mute. So jot down if you have any particular issue. We will attend to it. So that is the much you can take about measures of central tendency. Now we are looking at measures of dispersion. Measures of dispersion While measures of central tendency provide insight into the center of a data set, the measures of dispersion describe the spread of the variability of the data. It describes how the data spread. So the common measures of dispersion are the mean deviation, the variance, the range, and the interquartile range. So the mean deviation is similar. You find the mean deviation similarly the way you find the mean. If you have x up to n, you have x1 up to xn, then the mean deviation is given like this. You take each xi minus the s bar. S bar is the mean. When you have the data, you find the mean of the data and then take each value minus that mean. Each value minus that mean, you take the absolute value. Absolute value is a function that forces a number to become positive even when it is negative, because it's possible that some of the value will be less than the mean. So if you take a value that is less than the mean and subtract it with the mean, it will give you a negative value. And if we allow the negative value to be there, if we sum it, it will give us 0, and we don't want that. That is the essence of introducing that absolute value. Those strokes that you see here, that is what they mean. Those that are not mathematically inclined, that is what it means. Absolute value means the positive value. So when a number is negative, it becomes positive. When it is positive, it remains positive. So if the numbers have corresponding frequencies, just like in mean, when we calculated the mean, then the mean deviation is given by this. The mean deviation is given like this. You sum all the si minus s by times their corresponding frequency divided by the total frequencies. So find example now, we have to find the mean deviation of the corresponding of the following data. We have to find the mean deviation of the following data. This one is not a group data, it does not have frequency. So to find the mean deviation, we use the first formula, which is just to sum all the xi minus the x bar. So here the total n is 10, and the mean is the sum of all the values divided by 10, which will give us 90. If you sum all these values, you will get 90. And if you divide it by, sorry, n is not 10, n is 15. If you count it, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 values. This n that I wrote here is not correct. So is 90 divided by 15, which will give us 6. That is our x bar. So now the mean deviation is this. You now take, let me go show you in the table. This is the table. Here is the xi. Here is xi minus x bar, and here is the absolute value of xi minus x bar. So when x is 5, the mean, we calculated mean to be 6. So you do 5 minus 6, it will give us minus 1. And so when you take the absolute value of minus 1, you have 1. The same thing when x is 6, you do 6 minus 6, which is 0, and 0 remains 0. And so on. So you do all of that, and then you get your sum. You now sum all of them. The total xi is 90, and the sum of all the xi minus s bar is 60. If you sum the whole of this xi minus s bar that we sum, this is the absolute value. If you add all of them, we get 26. So when you do that, let's go back to the previous page. So the mean deviation now is going to be that 26 that we got there, divided by 15, which is 1.76. So the mean deviation of each value from the mean is 1.76. That is the meaning of mean deviation. What is the deviation of the x that we have from the mean? So we have values here, we have 5, 6, 12, 15, 10, like that. But the mean of the value is 6. So how far? What is the mean deviation of each value from the mean? So the next thing is the standard deviation. We have the variance and the standard deviation. So the variance is defined as 1 over n minus 1 into this. It's just like here is also the same thing like finding a mean deviation, but the difference here now is that when you take your xi minus s bar, you square it. Instead of taking absolute value, you now take the square. That is the difference between variance and the mean deviation. You take xi minus x bar. This thing that is here, when I pasted it, I don't know how it changed. This bar is supposed to be on top, supposed to be x bar. No, the bar is on top, not under. I will correct it before I send you the slide. At the end of the class, I will send a slide to you, and I'm going to collect this. This is supposed to be x bar. So you have, if you don't want to use this formula, you can use this one. This one and this one will give you the same result. Especially if you are using calculator. People that, if you are using calculator, it will be easier for you to take each xi and square it minus the sum of all the xi. You square them. So you can use this second one, it will be easier for you, but if you don't want, you can use the first one. They will still give you the same result. So now, where n is the sum of all the fi, as we've seen in the previous classes. So the standard deviation now is now the square root of the variance. The standard deviation is the square root of the variance. So you take the square root of the first formula, or you take the square root of the second formula, and that will give you your standard deviation. So let's look at that example. Consider the data on forced expiratory volume in 1 second. That is a medical term. Forced expiratory volume in 1 second in a sample of male medical students given below. Those male medical students that were measured have each of them will the expiratory volume per 1 second. So the mean value will found to be this. So to find the variance and the mean and the standard deviation, you group the data like this. You take the frequencies, you take the cumulative frequency, you take the frequency times the x values. The x value now, you take the midpoint between value between this. You have here 2.5. This 2.5 means that the value is from 2.5 to 3. That is this. From here now is 3 to 3.5. So you now take their half, their midpoint. So you have your x here. These are the x values. So you now multiply this x value by the frequency, which will give us fx, and then you square the x squared, because there's a x squared in the formula, and then you multiply the f times the x squared. So you now sum all of them. Here now the total cumulative frequency is 57. That is our n, and then the sum of all the frequency times x is this. So when you do that, you do the calculation, and you get your result to be the variance is 0.467 and the mean is 0.68. So that is much we can do with descriptive statistics. Now we are entering into inferential statistics. Just like we have two types of descriptive statistics, which is measures of central tendency and measures of dispersion. So under inferential statistics, we have two types of inferential statistics. We have what is called statistical testing or hypothesis. Statistical testing or hypothesis and statistical estimation. Statistical estimation. So now let's look at statistical testing or hypothesis. Hypothesis testing is a method of making decisions or inferences by making some assumptions or claims about the population parameters. It involves formulating a null hypothesis, that is the default assumption, and also formulating an alternative hypothesis, which is what we aim at proving. Then we use sample data to support that claim. So that is what it means to do hypothesis testing. What does that mean? It means that, for example, now you are making a claim that in Nigeria the average earning of a household in Nigeria is 100,000. That is a claim. That is a claim, and that is a null hypothesis. That is our null hypothesis. That is the default assumption. Now, the alternative hypothesis is saying that no, the average earning of a Nigerian household is not 100,000. It's not equal to 100,000. That would be the alternative hypothesis. You now take sample data. You will not be able to get all the household in Nigeria for you to find out what they are earning. So for you to do that, you will get sample data. It's either maybe you give a survey, or you give a questionnaire, or whatever means you may be able to get the data, or you go to Bureau of Statistics to get your data, and then you run your analysis to support your claim that the average earnings of a Nigerian household is 100,000. While the null hypothesis is saying that no, the average earning of a Nigerian household is not 100,000. So the null hypothesis can be two-sided. So these are the steps. I already started explaining it. The steps involved in hypothesis testing is that you state the hypothesis. First, you state the null hypothesis, which shows that there is no effect or difference in the status quo. What does status quo mean? The status quo is what you are saying is into existence. For example, now, this type of analysis is also used in the court of law. Somebody now took you to court and is charging you, is pressing claim that you have committed so crime, or you have committed so offense. So the status quo is that you have not committed any offense. That is a null hypothesis, because in the court of law, one is always innocent until he is proven to be guilty. So the null hypothesis is that you are innocent of the crime they are charging you of, while the alternative hypothesis is saying that you are not innocent, you are guilty. So they will now use the available data to support the claim that you are guilty, which they will be able to convince the judge to pass a sentence on you. So that is about stating the hypothesis. So the second step in testing or hypothesis is to choose a significance level. The significance level is called the alpha. This level is the probability of rejecting the null hypothesis when it is true. Now, the probability of saying that you are not innocent when you are actually innocent is what is called the alpha level. The probability of saying that the Nigerian household, the earning of a Nigerian household is not 100,000, The probability of rejecting that null hypothesis when it is actually true is called the alpha, is called the significant level. And the common choices are 0.05, 0.01 and 0.10. What does it mean? It means that if you take 0.05, you are saying that there is 5% chances of rejecting the null hypothesis when it is true. Or if you take 0.01, you are saying that there is a 10% chances, there is a 10% chance of rejecting the null hypothesis. There is a 10% chance of saying that you are guilty when you are not. And if you take, okay, 0.01, that is 0.01 means 1% rather. It is 0.1 that is 10%. So when you choose your alpha value, these are the common ones. You either choose 0.05, and depending on the area you are working, if you are working in the health sector, your alpha value should be 0.01, because 0.01, that is 99% should be correct. Because if you make a 0.5% error, 0.5% of 1 million people, 0.5%, sorry, 5% of 1 million people is 50,000 people. I hope you are 0.5% of 1 million people is 50,000 people. So if you take 0.5%, which is 5%, that 0.5% can cause damage. So in the medical line, they always take 0.01 instead of 0.05. But if you are working in the social sciences, 0.1 can be accepted, because the hypothesis cannot cause so much damage even when the error is committed. Then step 3 is that you compute the test statistic. The test statistic is a standardized value that measures the degree to which the sample data deviates from the null hypothesis. Then you determine the p-value and the critical value. The p-value is the probability of obtaining a test statistic at least as extreme as the observed value, assuming that the null hypothesis is true, while the critical value is the threshold beyond which the null hypothesis is rejected. So after you do all this, then you now make a decision, and this is how you make a decision. If your p-value is less than the alpha value that you choose, if you choose 0.05 and your p-value is less than 0.05, then you reject the null hypothesis. But if the p-value is greater than the alpha value, you will fail to reject the null hypothesis. Alternatively, you can reject the null hypothesis if the absolute value of the calculated test statistics is greater than the critical value of the as obtained from the table. So these are the types of statistics. We have the Z statistics. The Z statistics you normally use when the data is large, like from n greater than 30 and above. So let's go back to Excel and see how we can run those statistics. But before that, let me explain some of those. This is from the book. Those of you that have the book, what we are treating here is around page, here now I am on page 181. So when we are done with the class, you go there, you read through it so that you understand the concept clearly. And if there is any challenge, you raise it up, either on the platform or to my personal inbox. So now we are looking at, I started with Z statistics. Let's look at Z statistics. we have different types of those statistics. We are just looking at them. If you want to have a deeper understanding about them, you have to read this material and let me know if there are any issues. But if we are not inclined to having the background of statistics, we can just go ahead with our computations. So Z statistics is used when n is large, from 30 and above. So we have one sample Z statistics. This determines whether the mean of a single sample is significantly different from the known population mean. It is calculated as this. So when you take your data, you take the S value minus this mu here is the mean of the population, while X is the mean of the sample that you took. Then the decision is that you reject. Let me leave this area because I may be confusing a lot of people. What I will do about this is that I will do a tutorial video on how to compute those things. I will compute them manually and send it as a video to you guys, but computing them now, I perceive that I will be confusing a lot of people. So what we'll do is I will go to our Excel and see how we can compute those things in Excel. Let's see how we can do them in Excel. So we open our Excel here. We are opening, the Excel book is opening. We want to run this is the data that we are working on. This data that so let this data and paste it into a different sheet, into a different workbook, so that we work with it. I do Control C, I copy it, and then open a blank workbook here. This data, we want to run the descriptive statistics on it. So to run descriptive statistics, the first thing is that before you run analysis in Excel, you have to activate what is called analysis tool pack. So to do that, you come here, you come to file here, and when you come to file, you come down here, look at options here. If you are using Windows 7, you will see Excel options. Sorry, if you are using version 2007, it will give you as option Excel option. Here is just written option. So you click on these options. It's coming up. Now it has opened. So you now come here, look at add-ins. You click on add-ins. You click on add-ins. It's a little bit slow. Let's wait, let it respond. They are telling me that I say it's not responding. It's still coming up. Now it has opened. Look at essay up, essay add-ins here. Look at where I'm pointing, and then you click go. You click go here. It now opens this dialog box for you, and you now select analysis 2 pack. If you want to select more, you can add this one also, this analysis 2 pack VBA, but we are not using this for now. What we are using is analysis 2 pack. So you click OK. So as you click OK, I already activated it, so it just goes like that. But if you are doing it for the first time, after you click that OK, it will still open to you where you click the final OK, and then it will be activated. So when that is done, you come here, you click on data here. So when you click data, you see data analysis here. If you do not do that, you will not be able to see data analysis. You can see data, but you will not see data analysis. It's from here now that we begin to run our analysis. You click on that. Now it has opened for us. So what we want to run first of all now is descriptive statistics. You click on descriptive statistics here, and then you click OK. Now you will select the range, the input range. What value do you want to run the descriptive statistics? Is it all the data set? But this data set, some of them, they are not. If you select the whole data set, it will run the descriptive statistics on only the numerical values and leave out those ones that are not numerical value. You know, at the beginning I explained about types of data. We have qualitative and quantitative data. Like here now, this sales channel is a qualitative data. All these sales reps, all those things, they are categorical data. They are not uh, quantitative data. So you cannot run descriptive analysis with them. So now, if we do that, you now come to, let's run the descriptive analysis on those numerical value. Here we have unit sold, unit price. Let's select from here. You hold a shift key and move to this side and stop here. We are not selecting the order month and order year. So we now move, let's select like 100 values, or we can select as many values. Let's select this is up to 10,000 value. Let me select up to 1,000 of it. And now you now, but if the column heading, so click on open in a new sheet. We have column 1, column 2 up to column 6 that we selected. There's something, let me do it again. Let me go back to the data and run that analysis again. let's select together with the let's select together with the column headlines. Let's select here, will not go down far, stop at 100. Now we have, sorry, I have not even gone to, you go to data first, come to data analysis, go to the descriptive statistics, and then you select, it's still giving us the previous one that we selected. Let's select this one. You do shift key, you hold it and drag down. So we have selected 100 data points now. So we will now click labels in the first row. We click on this because we selected the labels, and then you do summary statistics, and then we do OK. So now instead of it to be like in the previous one that we did, that was giving us, where are we? Okay, this one, here is giving us column 1, column 2, column 3. But if we select another data came here, this is where are you, so the mean unit cost, sorry, the mean unit price is 5,252. The mean unit cost is 3,631, whether dollars or naira as the case may be. And then the mean total revenue is 2,291,164. That is the mean total revenue. And then the mean total cost is 1,579,402. While the total profit, the mean total profit is this. Then we have the standard deviation in the same way. We have the median, so all those things that we were calculating manually, in a single action. We have all of them here. We have the median, we have the mode, we have the standard deviation, the sample value. Let me scroll, let me move here so that you can see them very well. You see standard deviation, sample variance, the kurtosis, the skewness, the range, and all of this. So that is how you run descriptive statistics. So if you run this, if you are doing your work, you can you now copy this. You copy this and go and paste in your, maybe in your Microsoft Word. You copy, come to Microsoft Word and create a new file and paste it there. So this is it. So with this now, The ones that, if it is, for example, if it is your research work, like your thesis, your dissertation or undergraduate project, some of the value you don't need, you remove them and then keep the ones that are needed for your analysis. So that is how you run descriptive statistics in Excel. So the next thing now is to, by the way, you can, this one now gives you the whole of it, the whole of the descriptive statistics. If you don't want the whole of this to, you want to run them one by one. If you want to run it as on individual values, here now, let me cover and paste in a new sheet from here. Then open a new sheet that you average opens. It's now asking you to select the numbers that you want to take the average. So you now select this, you select this, you now select that, go back there, and then you close the bracket, because when you click average, automatically a bracket opened for you. You close the bracket. Now it's telling you that you are summing number from A2 to A51. You are summing the numbers from A2, because the A1 is the heading, so the number start from A2 up to A1, and so when you click enter, it will now give you the average. This is the average. What is a column? This column is what? Unit cost, right? Okay, unit sold. Unit sold. So that is the average of the units sold. Then what of unit price? If you want to take the average of the unit price, you also do the same thing. You type equals to, you type average, you select this, and then highlight this from here to where the data stop. When you finish highlighting, you go back and close the bracket. You go back and close the bracket. Look at the bracket is open here. You close it and then enter. Then you get your mean. That is how you will do. If you want to do, if you want to add, instead of taking the mean, you want to take the sum, the total sum of each of them. Here now you run equals to sum. Look at sum here, you click on sum, and then you now select the whole data set here. go back and close the bracket before you hit enter, otherwise you will not. This is a column for unit cost, the total unit cost, total so you do that. For that you can also add, you can take the sum row wise. If you don't want to add values vertically, column wise, you can also add values column wise. For example, here now, here is the unit price, here is the unit cost, here is the total revenue. And for you to know, supposing this total revenue is not given, you just have the unit sold and the unit price. For you to know the total revenue, is going to be the sum of, is going to be the sum of this total of units sold plus the unit, sorry, the sum of units sold plus the unit price. You close the bracket, you hit enter, and it will give you. You come to the second one here, you do the same thing, equals to, you do sum, you do this plus this, you close the bracket and you enter, it gives you, sorry, I'm doing the wrong mathematics here. It's not sum. To know the total revenue, is going to be the unit sold times the unit price. So here we do a not sum. You will do equals to this value times this value, and then you hit enter, you get the results. You can see that this value is the same thing as this. This is the value that you see here. Supposing this is not gotten from the data, but for the fact that you have this and this, you'll be able to get this. So you also do the second one, you say equals to this times the second one, you hit enter, and then you have it. So now you do auto sum to fill the whole of the area. You now look at this arrow down key here. You highlight the two of them, and then hold on this and drag it down to the last end of the data set. This is where it ends. You take away your hand, and then you have each value. That is the total. So that is how you do analysis. You do addition, you do multiplication, you do sum. We have a lot of them. As you keep working with them, you'll be discovering many things that you can do with Excel. So another thing that we want to look at now is how to run testing or hypothesis. How to run testing or hypothesis. So we have this data set here. I have this data. This data now, we want to run a t-test. This data is give you data on the number of participants, their age, the number, how many hours they exercise their body in a week. and what is the weight loss. What is the weight in kg that they do loss. So the question here now, the hypothesis that you want to test here, you want to see that does the number of hours that somebody exercise affect the weight loss. Is there any relationship between the number of hours you exercise your body and the amount of weight that you do that reduce from you. So to do this, we will run a test, we will run a t-test. So to run t-test, we use the same data analysis. You click on data here, come to data analysis, then come down to t-test. T-test. So if we click on t-test here and click OK, we now select our variable 1. Let's select, that is the number of hours somebody exercise their body. So we select this, and then we come to the input variable 2. We select the weight loss, and then we did not choose, we didn't select this, so there's no need to mark these labels. So we are testing this at 0.05. That is the alpha value I was explaining. The alpha value here is 0.05. If you don't want, you can change it to 0.01. Let's first do at 0.05 and also do at 0.01 to see the difference. So you now, let's open this in this same place. We don't need to open a new sheet. Click here, it will output here. So we now click OK. So this is our t-test. The mean for variable 1 is 4.6. The mean for variable 2 is 1.82. And the variance is this. The observation, each of them have 10 values, 10 observations. Then the t-test. The t-test, this is a t-test that is being calculated. The formula I gave you there, if you calculate, if you take this data and put into that formula, you will find a t-test of 9.63. So now the t-critical is the one from table. There are tabular value for it, but when you are using software like this, automatically you get, when you run it, it brings the value for you. But when you are doing manually, you have to get the t-critical from the table, and this is a 1/3 test. This is for 1/3 test. So the t-critical is 1.8. For the 2/3 test, the t-critical is 4.8. So the t-statistics, the calculated value, which is 9.63, is far greater than the t-critical. So when the calculated value is greater than the critical, we now reject the null hypothesis. We now reject the null hypothesis. And look at also the p-value. Where is our p-value here? Look at the p-value. The p-value is so small. It's so small than 0.05. So we now reject the null hypothesis and says that there is a significant this thing. There is significant relationship between the number of hours that somebody exercise himself, and the weight loss. The more number of hours you exercise, the more the weight you will lose. That is what it means. So let's look at another type of analysis that we can also do. Here now, there's a what we call regression analysis. Regression analysis tells you how you use regression analysis to predict future outcome. So here now, we want to here this data is about housing, the housing and the house prices. So we want to see, is there any ratio between the square footage, that is the size of the house, the number of bedrooms, and the year the house how old is the year, does it affect the price of the house? So to do this, we can run regression analysis on this. So to run regression analysis, you go to data. We are here on data already. You click on data analysis, and then we select regression, and you click OK. So you select the data set, you select your input range X. So here we are saying that these three, does they affect the price of the house? That is the size of the house, the number of bedrooms, and the year. How old is the house? Does this affect the price? So our input, which is the dependent variable now, is the price. We are trying to say that the price is depending on these three variables. These three, the square footage, the bedroom, the number of bedrooms, and the age of the house in years, they are independent variable. So our dependent variable y is now this. We now select this. We select that as our input. When we come here, we now select our dependent variable, our independent variables rather. We select the three of them as our input variable, and we click label here because we have selected the headings, and then we output this in a new sheet. We output it in a new sheet, and let's do normal probability plot. Let's click on that, and then also let's do line fit plot. Let's click on this also, and then you click OK. Okay, it's saying input range contains non-numeric data. I did not check this. I have to check this label here because I selected the input. I selected the column headings. So I check on this now. If I run this, I will get the result. Good. This is the result. This is our result. These are the probability plots. This is the probability plot. This is the line fit for years in age. This is the number of the age. How does age affect the price? This one is for the number of bedrooms and the price. Why this one is for the square footage and the price. So if we look at the model here now, if we look at this model, if you look at our results, it's now telling us that the t statistics is 0.09 and the p value is 0.39, and if we choose our alpha to be 0.05, this 0.39 is greater than 0.05, and when the p value is greater than that, you will now reject the null hypothesis. The null hypothesis is saying that the house price does not depend on the square footage, the age of the year, and the bedroom, while the alternative is saying that the price of the house depends on how old the house, how old is the house, the number of bedroom. So we now, with that, we reject the null hypothesis from this first one. The same thing with the square, with the number of bedroom. For the number of bedroom also, our p value is 0.67, which is greater than 0.05. For the number of years, our p value is still 0.55. So we reject the null hypothesis. So at this junction, I'm going to pause and give room for questions. I will now pause and give room for questioning.